Everyone, and welcome to The Explainer. I'm your host, and today we're actually going to become fluent in a brand new language together. We're going to act as your personal visual translator. Because let's be honest, if you've ever stared blankly at a page of raw data or just felt totally overwhelmed by giant walls of statistics, you are in exactly the right place. Today, we're taking those raw, intimidating numbers and transforming them into easily digestible, fascinating visual stories. We are going to decode the secret language of diagrams and graphs.
But first, we really have to address the elephant in the room. Why do spreadsheets make us so incredibly sleepy? Seriously, if looking at thousands of rows of data makes your eyes glaze over, you are definitely not alone. Extracting any sort of conclusion from a large, complex mass of numbers is genuinely difficult. Our brains just aren't wired to read raw data and instantly see the story. It's dull, it's exhausting, and frankly, it feels like a chore. But it absolutely doesn't have to be.
Okay, let's dive into this. Here's our quick roadmap for today. First, we'll talk about escaping the number maze. Then, we'll explore our core building blocks with bar charts, see how to stack up the details, and learn how to slice the data pie. Finally, we'll round things out with the rest of the toolkit.
So part 1, escaping the number maze. Let's look at exactly why visuals are the ultimate cure for that dreaded data fatigue.
Think about it like this. On one side, you have your purely tabular presentation, just walls of numbers. Like we said, it's complex, it strains the mind, and making sense of it feels a bit like pulling teeth. On the other side, though, we have visual presentation. This uses shapes, curves, straight lines. It's impressive, it's pleasing to the eye, and it makes drawing conclusions almost entirely effortless. When data is presented visually, it completely bypasses that mental strain. It leaves a strong, lasting impact on your mind. I mean, you're always going to remember the shape of a trend, long after you forget the specific numbers, right? The advantages here are just massive. Visuals completely eliminate the dullness of raw data and instantly create interest. They make comparisons incredibly easy. You just glance and instantly know which line is higher. Plus, by plotting time series data, we can establish past trends, which lets us fill in the blanks of today and predict the forecasts of tomorrow. Visuals even let us locate averages without doing complex math, which is a total lifesaver, and we'll touch on that later. And, perhaps most relevant to our everyday lives, they are absolutely crucial to advertising campaigns. Honestly, an ad almost feels naked without a strong visual effect to back up its claims.
Moving into part 2, building blocks. This is our deep dive into bar charts. I want you to think of these as the city skyline of data.
This brilliantly illustrates our very first tool, the simple bar diagram. Imagine you're standing downtown, looking at a row of skyscrapers. A simple bar diagram is exactly like that skyline. It tracks how a single variable changes, just like noticing which building on the block is the absolute tallest. It manages both positive and negative numbers with zero fuss, whether it's drawn vertically or horizontally. It is simply the most straightforward way to see how one single thing changes across a few different points.
But here is the golden rule you have to remember for the simple bar diagram. Only the height matters. The length or height of the bar is strictly proportionate to the magnitude of the data it represents. But the width of the bar? That has absolutely zero statistical value. None. It remains uniform simply to make the chart look nice and neat. Going back to our skyline analogy, if we're measuring how tall the buildings are, we don't care at all about how wide they are. We're only looking up.
Okay, but what happens when we want to look at more than one thing at a time? Imagine taking your monthly electricity and water bills and stacking them right next to your neighbor's bills. You're making a direct, side-by-side comparison of different variables at the exact same points in time. That's a multiple bar diagram.
In this setup, two or more bars are standing shoulder to shoulder. They represent different variables or maybe different components of the same variable over a period of time. Now, to make this easy on our eyes, the different bars within a single set are always colored or shaded differently, and an identical gap is left between the different sets of bars. This is how you instantly compare apples to oranges, side by side, month after month, without getting the numbers jumbled up in your head. Part 3. Stacking up the details. This is where we break down the whole. Instead of putting buildings next to each other, what if we want to look at the individual floors of one single building? Well, that brings us to the subdivided bar diagram, also known as a component diagram. Building one is a really logical step-by-step process. Step 1, you construct a single tall bar that represents the absolute total value of your variable. Step 2, you chop up, or subdivide, that bar in proportion to the values of its various components. And step 3, you base those divisions on cumulative figures. So think of your total monthly budget as a single bar. You're basically painting the bottom section blue for rent, the middle section green for groceries, and maybe an alarmingly large top section red for your daily coffee habit.
The crucial point here is how we standardize this, which introduces us to the percentage subdivided bar diagram. This is a brilliant little variation where we normalize everything. Basically, we put everything on an equal playing field. No matter what the actual raw numbers are, we treat the total length of the bar as exactly 100. Then, the length of each component inside it is expressed as a percentage of that total. It makes proportional breakdowns visually seamless. If your rent is 50% of your budget, it takes up exactly half the bar every single time, whether you're spending $1,000 a month or $10,000.
All right, part 4, slicing the data pie. We are pivoting from stacked blocks and straight lines over to circular proportions.
You might hear these called pie charts, or, if they have a hole in the middle, donut charts. But whether it's a pie or a donut, the underlying logic is exactly the same. We are taking a whole circle and dividing it up based on relative areas. It's essentially the visual equivalent of serving dessert at a dinner party and making sure the slices reflect who is the absolute hungriest. If one person did all the cooking, maybe they get half the pie, while everyone else splits the rest. We're dividing the whole thing based on relative share.
To define it formally, a pie diagram carves up a circle to show those relative proportions. But the math is a tiny bit different from our percentage bar. Instead of equating the whole thing to 100, the total value of all components is equated to 360 degrees. The total number of degrees around a central point. We then calculate the degrees for each specific component proportionally, to literally carve up the circle. It's just a beautifully intuitive way to show how individual pieces make up a whole.
And finally, part 5, the rest of the toolkit. We've covered the absolute essentials, the bars and the pies. But I want to do a quick speed round through the slightly more complex, specialized tools you might encounter out there in the wild.
First up, rectangles. Remember how I said the width of a simple bar chart doesn't matter? Well, in a rectangle diagram, it absolutely does. It's a 2D area diagram where one variable is the length and another is the width, meaning the total area is the product of both. Next is the histogram. This kind of looks like a bar chart with no gaps, where the width represents a grouping or range of numbers, and the area shows how often those numbers actually appear. And finally, the frequency polygon. This shows a gradual rate of rise and fall. You construct it by plotting the very center of your data groups and connecting them with straight lines. It creates this neat mountain peak shape that shows you exactly where the data clusters.
So, why do these slightly more complex shapes actually matter to us? Because of this fantastic shortcut, locating positional averages. Using specific graphs like the histograms we just looked at, we can actually find the median, the quartiles, and the mode without having to do any complex statistical calculations. The visuals do all the heavy lifting for us, literally pointing right to the center of our data trends. It's honestly like having a statistical calculator built right into the image itself.
There's a reason advertisers use these exact tools all the time. They know an ad feels incomplete without a visual effect, and they know our brains vastly prefer pictures over spreadsheets. So I want to leave you with this thought. The next time you see a bar chart, a pie diagram, or a rising trend line in an advertisement, just pause for a second. Ask yourself, what story are these shapes trying to sell me? What are they choosing to compare? And maybe more importantly, what are they hiding? Because now that you have this visual translator toolkit, you hold the power to see the truth behind the lines. Thanks so much for joining me, and keep exploring the numbers around you.